Well, hello, geometry students. What we just talked about was the things about lines and planes, uh, segments and points and rays and all of those such things. And what we need to talk about now is some postulates, because this is the beginning of geometry. And let me tell you, we're going to be proving so many things. It's going to be awesome, and you'll be able to do it in your sleep. But in order to do that, we need a base point. And that base point is postulates. As we mentioned yesterday, postulates are things that are just accepted in geometry as fact. And you can use those to prove other things. If we just assume that these are fact, not that they're proven, but they're accepted as fact. They're also called axioms. That's another term for them. But with that being said, we are going to start here with 4 basic axioms based on things that we talked about yesterday. All right, so the first one is, um, it says that 2 points determine a unique line. It makes sense to us as long as you have 2 points. Only one line, one unique line can go through 2 points. All right, you can't have any other lines than that one unique line. So that's our first postulate we can use. The second postulate here is it says that if 2 distinct lines intersect, then their intersection is a point. Okay, these are 2 distinct lines. They're not the same line. They're separate lines. We have one line here as an example, one line here, line L, and then line M. And again, those have arrows because they go on forever. But you know that. And it says that if they intersect, their intersection is a point, just one point. Not multiple points, just one point if they're 2 distinct lines. And that point is represented by T here. All right, the third postulate that we can talk about is right here. It's about planes. It says that 3 non-collinear points, that means 3 points that are not on the same line, determine a unique plane. So you have 3 points here. They're not on the same line. So that means they can determine one plane. There's only one plane that goes through all 3 of those points. And you can call that plane ABC if you'd like. You could also call it BCA, ACB. You get the point. On to our last one. The very last of the 4 that we're going to talk about is this one where planes intersect. It says that if 2 distinct planes, not the same plane, they're distinct planes, intersect, then their intersection is a line. So we said before that if 2 distinct lines intersect, they create a point. This is kind of a step higher in saying 2 distinct planes create a line. So we have plane P and plane Q, creating this line AB here. It's the only place that they intersect on that line. So again, this line is going to go on forever, just like these planes go on forever in those directions. But now a couple things that we could use this for. First of all, and these are in your notes. This is straight from your notes. First of all, the number 1, it says name all the different lines that can be drawn through these points. Okay, so there's a whole bunch of them. And you can think of AB, you can think of DC, you can think of BC, you can think of BD, you could think of AD, you could think of AC. And that was a little bit off, but I believe those are all our lines. So we have AB, and remember, lines need to have the arrows on top so that we know that they're lines. We have BC and CD and DA. We also have AC and BD. And you could also call some of these lines different. You could say BA instead of AB, CB instead of BC, and so on. But those are the 6 points or lines that we can create going through those 4 points. Now, number 2 here says name the intersection of points A, B, and DA. So I will draw AB here in blue, and DA will be in green. And again, I apologize, they're not perfect. I don't have the steadiest of hands, especially on this screen. But the intersection, those intersect at this one unique point. Based on our postulate, we know that two distinct lines intersect at one distinct point, which would be, in this case, point A. So that is our answer. And again, points are represented by one capital letter. Number 3, name all the planes that are represented in this figure. So there are so many different planes. All you need to do when you're listening a plane, for instance, this gray one here that I'm going to shade also in yellow, all you need is 3 points. So we know 4 points that are on here. You can call it G, F, J if you want. So that'd be plane G, F, J. You could also say that would be plane, well, let's do a different one. I'll do a different one in green. This front one, we'll call it H, K, G. Now there's other different ways of saying it, but you're going to find that there are a total of 6 planes here that make up this box or this rectangular prism. And that's just how rectangular prisms are. There's a whole bunch of planes, and if you notice, based on that postulate, if 2 of these intersect, they make one distinct line. And that would be our postulate number 4 here. All right, going on to number 4, name the intersection of planes DEG and IJF from the figure above. So here we go. Here's that postulate. The intersection of planes DEG, which would be on the top. We can do that. I will erase this. So the top is DEG, and IJF would be the back. So if we're going to do the back, that'd be way back here. And if you look, there's that one line they intersect. And I have it a little bit covered up, but I believe it is EF. So it would be on line EF. And if we're looking at the box, it would really just be a segment. So you can write a segment EF. That would be acceptable as well. And then the last one, are points H and F collinear? You have point H and you have point F. Are they on the same line? I don't think so. They're complete opposites, so I would say no. There's no line, unless you make a diagonal line that goes through, there is no line that they're on that is together. So this is day 2 of talking about points, lines, planes, etc., and introducing postulates today. So we didn't use them to prove things, but we talked about different aspects where they are involved in geometry. And we're going to be doing a whole lot more with postulates in the time to come. So with that, have a good rest of your day.